Yesterday, we talked about what made a parallelogram a parallelogram. Today, we're going to talk about, well, is this actually a parallelogram? So yesterday, we talked about a parallelogram, and a parallelogram, our definition was a parallelogram is a quadrilateral that has two pairs of opposite parallel sides. And then we had four qualities that kind of went along with it. We had the fact that opposite sides were both congruent, opposite angles were congruent, consecutive angles were supplementary, and then lastly, we know our diagonals bisected each other. Today, instead of saying, hey, this is a parallelogram, and here are its properties, we're going to take a peek at our conditions. We're going to say, yo, this quadrilateral is a parallelogram as long as one of these 6 rules exists. We should know these rules. Yes, sir. We should.
I saw you threw in the proof in the last problem on math lab yesterday.
I did.
I got it right.
Good.
Right too. On the second try though.
It's probably because today we're doing a lot of proofs.
Oh.
Wow.
Oh,
Wow. So, if a quadrilateral seeks to be, grab it for me, brother, a parallelogram, it must meet one of these 6 criteria. It just needs one of them because then the rest of them are true. Our first one is the definition of a parallelogram. Both pairs of our opposite sides are parallel. This is our definition. If this is true, then we have a parallelogram. Or we could prove that both pairs of opposite sides are congruent. If both of our pairs of opposite sides are congruent, we have a parallelogram. Both pairs of opposite angles are congruent. If we can prove both pairs of opposite angles are congruent, we have a parallelogram. Number 4 is kind of different. We didn't talk about this one yesterday. For number 4, though, if one pair of opposite sides is both parallel and congruent, then we have a parallelogram. If we can prove that, we're in business. Our 5th one, if we can prove that an angle is supplementary to its consecutive angles, then again, we have a parallelogram. And then finally, if both diagonals bisect each other, we've got a parallelogram. So these are our 6 rules we're going to deal with today. And then they'll pop up through a couple of our proofs as well. Example 1, determine if each of the following are a parallelogram. If they are, give a reason. So our reason is going to come from one of our 6 rules. So looking at A, is this a parallelogram?
Yeah.
Why?
You have congruent angles on both sides.
Do I have congruent angles?
Is that what that thing is right there? Congruent sides.
I have congruent sides.
Oh, I know your sides. I just thought that.
But if I'm doing congruent sides, it has to be both pairs. I've only got one pair.
Don't you, if you have,
They're parallel.
Yeah.
The one pair of sides they give me is both parallel and congruent. So this falls under rule number 4.
I'm laughing.
For B, we've got to check, is this a parallelogram? So we've got to test, which rule do you think we're going to try to use?
Angles.
Number 5, where it says angle is supplementary to both of its consecutive angles. So what do we need to check? Well, they are consecutive because they share a side. We need to make sure that they add up to what? Is 115 plus 65 180? Yes. So is this a supplementary relationship? Is the other a supplementary relationship? So is 115 supplementary to both of its consecutive sides? Yes. So we have a parallelogram based on rule number 5. C. Is this a parallelogram?
Yeah.
No.
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 No, because
No.
I know why.
Sides are.
It's got two pairs of congruent sides, though.
Oh.
Because the sides are not opposite, it is not a parallelogram. Good. Congruent sides are not opposite. So no, C is not a parallelogram because the congruent sides are not opposite. Now we get to D. Oh, the answer's on there.
Yes.
No, I actually didn't see, so I have no clue.
Is D a parallelogram?
Yes.
I think so.
Yep. Parallel sides.
Okay, so it's got a pair of parallel opposite sides, but in order to use rule number 1, what must be true? The other ones also have to be parallel. Is that true? What do you mean the thing in the middle? Okay, so what does the diagonal rule tell us? You need both. Do we know about the other one? So we're only given one bisected diagonal, one pair of parallel sides, but wait, we have a rule that says we can use one pair of parallel sides as long as what? They're also congruent. Do we know if they're also congruent?
Maybe.
What do you mean maybe?
Maybe there's some type of.
So the only rules we got are the 6 above, right? So do we have enough information to say that this is or is not a parallelogram? It looks like it, but we can't go on looks because it's geometry and you can't go based on looks. Can't judge a parallelogram by its picture.
Ooh.
What if we talked about this? These are parallel, correct? And then this is a transversal, correct? So what do we know about these two angles? We know that those two angles are congruent. All right. Well, that doesn't get us a whole lot of nowhere. What is it? You got the others? Oh, so we know that these angles are congruent. But that doesn't, hey, what is that? That doesn't help us with our parallelogram yet, though. Right? So we know that alternate interior angles are congruent. We can confirm that. There is something that we know about this picture. Gentlemen, ladies in the room. What is that shape? Those are triangles. Well, What do we know about these green triangles? Our triangles are congruent. Because our triangles are congruent, what else do we know about the relationship in these two green triangles? What's that? Vertical angles. Well, I don't need anything else with angles. I'm good there. But what about this side? Because the triangles are congruent, what can we say about those purple sides? Why? But why? But what makes the sides congruent since the triangles are congruent?
What is that?
Corresponding parts of congruent triangles are congruent. So because my triangles are congruent, my other sides are congruent. So is this a parallelogram? Yep. I love that that's number 4 because it leads us right into our proofs.
No.
Let's go to number 8. Let's go to number 8. Parallelogram proofs. Why is it a parallelogram? So, given EDG is congruent to GFE, prove that DEFG is a parallelogram. So how do we know that the triangles are congruent? Yeah, they told us so.
So then what do we have to prove?
We're proving, so this statement here at the end, that's our prove statement. So prove that DEFG is a parallelogram. That'll always be, is that all right, KMLA? DG is congruent to FE. How do we know that? So it says right here that DG is congruent to FE. What makes that true? What's that? No, you'd have to write the description because it's not a universal that we're just saying, hey, that's rule. Why is DG congruent to FE? Well, that would be true as long as it was a what? Do we know that it's a parallelogram? We're trying to prove that it's a parallelogram.
That's why it's called a proof.
That's why it's called a proof. Looking at statement 1, what did they give us for statement 1? That the triangles are congruent. If the triangles are congruent, what does that mean about the remaining pieces? They are also congruent. How come? Corresponding parts of congruent triangles are congruent. CPC, TC. It's almost like a review before your final. What? DE is congruent to FG. How come? What makes those two congruent? Corresponding parts of congruent triangles are congruent. Right. So DEFG is a parallelogram. How come? What makes DEFG a parallelogram? What did we prove in statement 2 and 3?
Sides and
Opposite sides are congruent.
there we go. What is CPC?
Corresponding parts of congruent triangles are congruent. It's just, you don't write the O and the A. That wasn't too bad, right? Oh, well, if y'all thought that was awful. So number 11, BA is congruent to BE, and CBE is congruent to EDC. How do we know that? It was given. Let's go ahead and mark it up on our diagram, because something with 13 steps, we're probably going to need some pictures. So BA is congruent to BE, and then CBE is congruent to EDC. Did I mark that right? Yes? Statement 2, triangle ABE is an isosceles. Why is it an isosceles? Two congruent sides. So what do we call that? Definition of isosceles triangle. A is congruent to BEA. So that would be this two angles. A is congruent to BEA. Why is that true? What makes A congruent to BEA? But what happens in an isosceles triangle? Base angles are congruent in an isosceles triangle. Great job, dude. So base angles are congruent. Fantastic work. But we needed to prove what first before we could make that statement? That it was an isosceles triangle. All right, next one. Measure of angle A is congruent to the measure of BEA. What happened from 3 to 4? What changed? It went from congruent to equal. What do we call that? Definition of congruence. That's the one that allows us to bounce back and forth. All right, number 5. A and C are supplementary. How do we know that? What's up? How do we know A and C are supplementary?
A and what?
A and C are supplementary. How do we know that?
Opposite.
What's that?
Given.
Given. It was part of our given information.
Wow.
That's good.
Yeah, you could have read something else.
All right, what about BEA and BED? So that's these angles right here. BEA and BED. Why are those supplementary? Yep, linear pair. Number 7, A plus C equals 180. A plus C equals 180. Where did we get that from? A and C are 180. Look at statement 5. What did we say in statement 5? A and C are supplementary. So statement 7 says the measure of A plus the measure of C equals 180. How do we know that? It's not given. Definition of supplementary. Number 8, BEA and BED are equal to 180. Same thing, definition of supplementary. Nine, BEA plus BED equals measure of A plus the measure of C. What did they do? let's highlight, where did we see the measure of BEA and the measure of BED? Where did we see that at? Statement what? Statement 8, right? And then we've got measure of A plus the measure of C was in statement 7. So what did they do from 7 and 8 to create 9? So when somebody gets replaced in a game, what happens? Substitution. You're not that far off. So transitive and substitution are pretty interchangeable. So substitution, POE, and then statement, what was it, 7 and 8? Number 10. A plus, hey, we're almost finished. A plus BED equals A plus C. What happened from 9 to 10? What's different from 9 to 10? BEA. What happened to BEA? They replaced it with who? A. So what do we call that? Substitution property. Step 4 and 9. Hey. BED equals C. What happened? What'd they change? They subtracted, yep. They subtracted angle A from both sides. BED is congruent to C. Definition of congruence, it allows us to switch back and forth. Def of congruent. And then 13, BCDE is a parallelogram. So let's go, which ones did we just say? C was congruent to BED. So what makes that a parallelogram? Opposite angles are congruent. See, wasn't that fun?